Hello and welcome. This is question 4 of January 2012 Edexcel C4. So what I've done on the board here is I've drawn, basically we are told in the question, we've got an equation for the graph y equals a square root of 2x over 3x squared plus 4, and we're told this is rotated around the x-axis 360 degrees, so it's not going to be anything other than that in this A-level, and then we are told that it's between the limits x and equals 0 and x equals 2. Now, don't be put off by it's a square root of 2x over 3x squared plus 4. Don't try and square root that or anything to do with that, because in the formula we end up squaring the equation of the line or the curve or whatever it might be in this case. So you don't need to worry about that. Although I would say this kind of helps reading the question, because you might see this equation and think, oh, well that looks like an impossible equation and it's something to do with the area, and if you haven't read properly the actual what it's asking, you might start trying to do the trapezium rule, which is be the area for that, but it'd be pointless. I mean, you probably could do that, but it's not what it's asking, so it's key to read the question. So anyway, we said find the area of S. Now S looks something like that, if you excuse my rather crap drawing. So we need to remember, well, what is the equation for doing the formula of the of this thing? Well, if there's two curves, you would do the top curve, take away the bottom curve. But we only got one curve, so we were all right with this. So therefore, it's just pi times the integral. I'm going to put limits a and b, a being equal to 2 and b being equal to 0, because the upper limit is 2 and the lower limit is 0. And that's the integral of y squared with respect to x. And now I did a proper video about this, and I said whenever you're doing rotating around the x-axis, it's the y coordinates that are changing, because you're introducing this positive and negative version. So when you integrate it, it could be either positive or negative, so that's why we have the squared part of this. And the pi is just working out the area, it's just a method for working out the area. Okay, so we put in what we've actually got here. So if we take this a bit further, so I'm going to solve it right, pi times the integral, I'm going to put the limits 2 and 0. And we've got y squared. Now instead of writing, so I'm going to, well, you could either write this as square root 2x over 3x plus squared plus 4, or you could just write, what I'm going to is 2x over 3x squared plus 4 to the power of a half, which is the same thing, times by 2, or squared, sorry, and that gets us, therefore, it's pi times the integral between 2 and 0 of 2x over 3x squared plus 4. Okay? So the first thing we need to do is integrate this. Okay, so you can take that out, you could do this on a side bit of the paper, but I'm going to continue with this. Okay, so still write pi at the front, times, and I'd write square brackets here, so this is the actual integral. Now, for integrating this, you can't really use any other rule apart from ln. So what we said is the ln of the bracket, so sorry, these new pens have ordered the wrong pens, so it's the ln of 3x squared plus 4, and the derivative of 3x squared plus 4 is 6x, and that's 2x, so it's to get from 6x to 2x, you times by a third or divide by 3, so it's a third of the ln of 3x squared plus 4, or ln of 3x squared plus 4 over 3. As I said, I explained how to do this in a proper side video, so I'm assuming you get that, but if you don't, please do watch my video. So it's pi times the, I'm going to write it all as one fraction actually, so the ln of 3x squared plus 4 over 3, and that's between the limits 2 and 0. And then it's just a case of working it out like you would work out any other integration question. Okay, so it's pi times, and then you substitute the numbers in, so your ln 3x squared, so 2 squared is 4, times 3 is 12, 12 plus 4 is 16, so it's the ln of 16 over 3, or third of the ln 16, oh sorry, I do it more in the square bracket, that's minus the ln of 0, 3 times 0 squared, which is 0, plus 4, so it's the ln of 4 over 3. Now, he's asking us to find the exact value. So what I'm actually going to do is, I mean, you know, you could keep that if you wanted to. I'm just going to rub it out, this last little bit here, because I want to rewrite this so we can see, because ln, what it actually says is the natural log of x, so it's going to be using log rule, so it's a third times the ln of 16 take a third times the ln of 4. So as they're both times by a third, we can just use the log rules. So it's pi times a third times the ln, or third ln. And because it's the ln of 16 take the ln of 4, it's the ln of 16 over 4, which is 4. So I'm just going to write 16 of ln of 16 over 4, which we all know is 4. And you can change that going back to 4. So it's just a third times the ln of 4 times pi. So therefore, to put this in exact form, because we can simplify this down a little bit. Okay, so it's pi times the ln of 4, and that's all over 3. And that's an exact form. So remember, that is equal, put that as the area of S when rotated around the x-axis. Okay, so that's the answer to question 4. It's quite a nice question, really. I mean, the main part is understanding this formula and just realising this basic power rule, indice rule, and then here it's just using the ln. So it's actually a mix, really. This question is a mix, so it's not one straight topic. So it was the volumes of revolution and integrating to get ln. Okay, so it's, as I said, it's quite a nice sort of, is it 5 marks? So there's no other part, so that is question 4, there's no part A, B or C, that's just it. So thanks for watching and well done for making it through. Hopefully it hasn't been too dull, and we'll see you in another video sometime, hopefully, if you make it.